Hello, I Kiran Mudroti, Assistant Professor, Department of Computer Science and Engineering, Ballari Institute of Technology and Management, Ballari. Welcome you to yet another class of system modeling and simulation. In the previous video lecture, we started module 3, random number generation. Uncovered KS test and chi-square test. Both are used for random numbers are uniformly distributed or not. That is test for uniformity. And in this video lecture, we begin with autocorrelation test. It is used for checking random numbers are independence or not, independent or not. That is test for independence property of random numbers. Autocorrelation test is concerned with basically the dependence between the numbers in a sequence. For example, if the random numbers are generated with the help of linear congruential method or combined linear congruential method, if the numbers are like 10, 20, 30, 40, you can easily guess the next number as 50. How exactly the difference between the two numbers in a sequence like arithmetic progression, geometric progression, or harmonic progression, it is a constant. Okay, so we can easily guess the difference between 20 and 10 is 10, 30 and 20 is 10. So we can easily guess the next number. So these are dependent. This is not actually the property of random number. The random number property is one value does not dependent on another value. So it is not going to be accepted. It is going to be rejected. For example, if I generate a random number like 7, 0, 1, 9, 3. So look into this. 0 is not at all dependent on 7. 1 is not at all dependent on 0. Similarly, 3 is not at all dependent on its previous value. So it is very difficult to guess the next number. So this number is accepted. So this property is called independence. It is one of the basic property the random number should possess, that is independence. If there are large set of numbers, it is very difficult to guess or too difficult to test whether they are dependent or not. Okay, for that reason we are using autocorrelation test algorithm. Let me take you to the algorithm. Autocorrelation test algorithm. Autocorrelation algorithm follows these steps. Totally 8 steps are there. Quite simple in understanding all the steps. First step is define the hypothesis for independence. Hypothesis in the sense assumption. I'm doing an assumption H0. Hypothesis 0 is nothing but I'm calculating a row of IM. If its value is equal to 0, then the numbers are independent. If it is not equals to 0, then the numbers are dependent. That is my first step. Step 2 is find I and lag M. Lag I is nothing but it is the initial number. M is the constant. Using I, M and capital N. Capital N is nothing but the total set of numbers given. How many numbers are given? That value is called N. And find M. M is nothing but largest number. It is also given in the problem statement. By this one, if this condition is true, then we are going to move ahead with next step. Okay, I'll explain this step and all the steps with example. At that time, you come to understand clearly. Let us move ahead with step 4. Step 4 is a formula to calculate rho of im is equals to 1 divided by m summation of I value 0 to n r of I plus km into r of I plus k plus 1 into m minus 0.25. Similarly, step 5 is finding standard deviation of estimation. Sigma of im is equals to square root of 13m plus 7 divided by 12 into m plus 1. If we calculate step 4 and step 5, that is rho of im and sigma of im, so we can easily calculate with the formula z naught is equals to rho of im divided by sigma of im. Once if you calculate z naught, the second step is determine z alpha or za from a standard table which will be given in the exam. So you need to compare uh, z naught with z alpha. If it is less than or equals to, if this condition is true, then we are going to accept and there is no dependence between any numbers, so we are going to accept, otherwise we need to reject those random numbers. This test is called autocorrelation test. I'll take you to the example so that you come to understand all the 8 steps, step 1 to step 8. So let me go with example. Consider the following sequence of numbers. Okay, totally there are 30 numbers are there. Look into this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 and totally 30 numbers are there. So n value is equals to 30. And test whether third, 8th, 13th and so on numbers in the sequence at the beginning of this section are correlated using alpha value is equals to 0.05. So here test whether third means it is beginning of the number is I. I stands for initial number, that is my third number 3, and third, 8th and 13th, the difference is m is what, the constant between one number with another number, that is 5 for every 5 numbers. And the first condition should follows. In the third step, I plus m plus 1 into m. Here what happens, I value is 3 plus m value is how much, it is given 4. 4 plus 1 is 5. 5 into 5 is 25. 25 plus 3 is 28. 28 is less than 30. So the condition holds good, that is step 3. Then we need to move ahead with step 4. Step 4 is nothing but using the formula we are calculating. This is my step 4. I am using the formula. So 1 divided by m value is given, that is 4 plus 1 into summation of I value is what, 3, third number is 0.23, so I'm going to take 0.3 into ri plus 1, k plus 1, so yeah, the difference is 5, so I'm going to take the next fifth number, this is 0.23, 1, 2, 3, 4 and 5, fifth number is 28. 0.23 into 28 plus 8th number is what, this is 8th number 0.28, so 0.28 into its next fifth number, that is 0.28 is the 8th number, so next fifth number is 1, 2, 3, 4, 5. So this is 0.33. So I'm going to multiply with 0.33. Similarly, you need to do it with all the numbers. 0.33 into 0.27, 0.27 into 0.05, 0.05. That is my 13th number. That is like that it continues, and you need to compute this value. calculate using calculator. You calculate and we will get the answer minus 0.1945. And this is my fourth step. And fifth step is sigma. Sigma of im is equals to square root of 13m plus 7 divided by 12 into m plus 1. So m, m value is already given, that is 4. So square root of 13 into 4 plus 7 divided by 12 into 4 plus 1. If you calculate this, you will get an answer 0.1280. Then z0 value we need to calculate. Z0 value is nothing but this value divided by this one, that is rho of im divided by sigma of im. So if you divide these two numbers, I'm going to get the answer minus 1.156. Using this value and given alpha value is how much? Alpha value 0.05. From a critical table, it will be given in the exam. That value you need to find out. So I'm going to take minus 1.15. Okay. So look into this. This is positive value table. This is negative value table. So my table is 1.5 is a z value and 0.05 is a alpha value. Once if you drag it, you will get in between 0.93 and 0.94. It is approximately equals to 0.95. Similarly, if you take this one 0.04 and 0.048, if you add it, you will get approximately 0.95. So the next in the table values, there are some common critical values. If the value is 0.95, so the critical value is 1.96. So from that table, from the given table, I got the answer Z alpha, that is Z 0.05 is 1.96, and I'm comparing it with the Z0. Z0 is compared with Z alpha and Z0 is minus and this is plus. Of course, it is less than Z alpha. So therefore, hypothesis is not rejected and this given set of sequence number 3rd, 8th and 13th and so on are not dependent. So it gives a chance to say that the given sequence of numbers are not dependent. That means the property is independence. So we are going to accept these numbers. Okay. So this completes random number generation chapter. Okay. So we covered totally KS test, chi-square test and autocorrelation test. And copy this assignment and also take video question paper and solve some other examples related with autocorrelation test. Namaskar. Thank you for watching.